Bismillahirrahmanirrahim. Assalamu alaikum students. Today's course is Semantic Web with the course code CS673, and I'm your instructor Ms. Amreen at University VVSUI. Today's topic is continued from the last topic that we had discussed in lecture 8, and today's lecture is lecture 9 with the topic Basic SPARQL Query Programming Skills. Today's lecture has a continuation from the previous lecture, lecture number 8. So today we will see about the query structure in SPARQL. A typical query includes the following structure. Some parts are optional. Here are some query structure where some parts are optional, and the sum of them will declare about some clause where we can insert the query for result. Like first prefix, then query result clause, select first clause, where we can define the dataset that can be optional for us, from like location, the query pattern, where in the where clause we can write at the URI of the ontology from where the data can be seen. Okay, these are the query modifiers which can be optional, grouped by having order by, limits, or offset, or values. The modifiers which are used like as an object property, like some relation or subject and an object, and how they are modification to fetch the data from the data set relatable in the ontology, which is created while using the tool protege. There are some common prefixes, so we will be seeing the first 3 prefixes, and the rest of 4 will be discussed in the upcoming next classes. These are the 3 prefixes we will be dealing with: RDF, RDFS, and OWL. Resource data framework, and the framework schema, and the OWL language. So the first, how to select. Similar to its use in SQL, select in SPARQL allows you to define which variable you want to value return and out. Similarly, what we do in the SQL, we can be fetching the data from the SPARQL by using the clause select for the variable that we want to return or output the value. SQL, you can list these individual while using the asterisk to specify some values for each variable. Like in SQL, whenever we need to specify some value, we use the asterisk. Over here, we will be doing the same, like select question A, and again the text over here, the asterisk is representing for the value which will be defined. If you don't want to duplicate, you can append distinct after select. Example, select distinct country. Like suppose if you don't want to make like fetch the result duplicate, similarly you can amend distinct after select clause. How to program inside where. Second, the where clause. The where clause defines where you want to find the values for the variable defined in the select clause. Like where clause will define from where the location, the path from where you want to find the values for your variable which are defined in the select clause. Triple representations. As we have seen in the previous classes when we were just dealing with them. So over here, the basic unit is a triple, which is made up of 3 components: subject, predicate, and object. Each of the 3 components can take one of 2 terms, like put a prior to the variable name. The first condition, what we can do, we can put the variable name. Example, like the first, a universal resource identifier. It will work similarly like we are searching for the URL. Over here, it is the identifier but not the locator in the ontology. A prefix for the namespace for the URI can be utilized. These triples can be concatenated together using the full stop. These triples, the subject, predicate, or object, can be concatenated while using the full stop. Interconnected graph of nodes joined by the relationship is built up. Obviously, like there's an example for subject and object, whatever they are linked with the relation, so which can be deal or interlinked over here too, like education, and we have its facilities. So what facilities education has? It is providing us a complete education or the complete program details with whatever is being taught in that. तो ये हमारे पास रिलेशन हो जाएगा एजुकेशन और हमारे पास स्टडीज एजुकेशन studies comes under the heading of education. Education can be online. Online education is useful, or some other examples that we can see over here. Clause. A union clause, the result or match at least one of the multiple patterns. Like union clause, what it returns the results to match at least one of multiple patterns. Whatever the multiple patterns we have, it will be fetching the results for at least one of them. Like suppose there are the three classes with the same name and the object properties are different. So what we can do, we can filter that and can fetch the results for any one of the class for that time. Optional clause that is used often, and the filter to filter the result or to filter the result based on the certain condition. Whatever the conditions we want, we can use the filter clause to filter up that class. Suppose we here is an example. We have created a class in an ontology. We have designed an ontology, and there are a few classes. What we can simply do, we can use the filter clause to find out the specific class like education, and inside the education we have a class online. So I want to filter the online class only. So for that I may be using the filter clause which will be giving the results for some conditions. How to use modifiers. There are the modifiers which can be used. Here are some modifiers with the description, order, put solution in order, projection for the certain variables, like when we need to choose some certain variables, we need projection, distinct, how are the distinct in the sequence or unique, reduce to permit elimination, offset, control where the solution start from in the overall sequence of solution, limit to restrict the number of solutions. SPARQL examples to query RDF triple store. Okay, here are the few examples we will be seeing along with the SPARQL query or the SPARQL script. This section provides many examples on how the query of the RDF triple store. Example 1, find all class containing ontology graph. Like in the first example, we have to find all the classes which has the ontology graph. Okay, so this is the data sample for it, the example, the scenario, and the second example. It is aimed to find all ontologies in an RDF triple store. Typically, every single ontology include at least one class. This is SPARQL script searches those ontology graph in the RDF triple store that contains at least one class. This is a data sample which is generated while seeing the example or the scenario. So whenever the scenario is given to us or the example is given to us, what we first do, we are creating its data sample, and then we are writing its SPARQL script. Over there you can see syntax or the for it prefix is used over here, and we here select distinct like graph, again the URI from where we need to find the class. So OWL class, and here the URI from where we are searching. The URI will be the address of the ontology which we are working on, or from where the data can be seen. Example 2, find subclass of an ontology term. In the previous example, we were searching for the classes, and in the example 2, again, we are searching for the subclasses. So example and its data sample. Like this example is aimed to find all subclasses of an ontology term. This is the data sample for example number 2. Below is the SPARQL script prefix, and then again we need to distinct label from URL from where, from the subclass of, and then label like what we want. We want the subclass and then its URI address. Example 3, find the number of all class. Like here we have to find the number for all the classes like object properties, data property. So in that we again need to make a data sample. This example is aimed to find the number of all class terms of an ontology. where we need to find the number of all classes, like how many number of classes in terms of ontology are there. So below is the script. Select again from the URL where. So we have seen this whenever where we are using the from, where, or the select clause. This we have seen in the previous slides as well. Okay. So what we are writing, the variable that we are searching for, and from where, and what the filter that we are applying, that is the regex over here. Okay. Example number 4 is to us. We have example number 4 here. Retrieve definition and authors of all the classes in an ontology. What we need to have, we have to retrieve the definition of an author. So the data sample, this example, so the data sample for the above example is to retrieve the definition of all classes that have definition in an ontology. So here we can see in the SPARQL query or the SPARQL script, first we need to define the prefix, and then author, select clause, what we need, definition, and then author from the URL of an ontology, where, class, its label, again the IRI, and the definition that we need to search for the author. So over there, the author that can be obviously person. So the data will be fetching the result as per the author, which are mentioned, described, defined in that particular ontology. Example 5, retrieve general annotation of an ontology. This example is aimed to retrieve general annotation, description of the ontology. The result will return different types of annotations, such as a creator. Over there, the example 5 is asking to retrieve the general annotation for an ontology. So here, we need to find the result that will return the different types of annotations like creator. We can see in the script prefix, we need select distinct in the select clause, again the URI, and where we need to find out from the ontology, and that variables can be like a creator, can be a person. So we used over here. Example 5, theory on exam, find the vaccine containing egg protein allergens. We need to find the vaccine that contains egg protein allergen. The above examples are mostly based on ontology annotation properties, how to perform SPARQL queries based on logical axiom with object properties or relations. Here I provide some examples, like how to perform the SPARQL query for this basic axiom, like a logical axioms when it is needed to find out the vaccine containing related some protein allergens in eggs. Such a SPARQL script over here, we have seen the prefix has vaccine allergen, the URI, chicken egg protein allergen, again the distinct vaccine label from where that query, where vaccine, and then label RDFS subclass of vaccine. Restriction is vaccine restriction from the property has vaccine and allergen, some values from the chicken eggs protein and allergen. This is the way to write up a SPARQL query for the above problem, or we can write in this manner too. Like we need to define the prefix simply, select clause where we can distinct the label from the URL, from where we need to fetch the result, its label. In the RDFS subclass of, we need to see variables, OWL on property, and then some values from or over here. So what is the difference? Note that the following code has the same effect as the top code. Whatever we have seen in that, so like we can see there is no script difference in it, only the writing or the reading style for the user, in which manner she can write up the query for related problems. So this is the one way, and the other way for writing up the code for SPARQL query for such problems. The difference between the above two sets of SPARQL code is that the first one looks easier to read, obviously, as per the second one. Okay, so I hope this lecture is useful to you. And whatever the queries are related, you may ask. Inshallah, we'll be coming back with the next lecture. Take care. Thank you so much. Allah Hafiz.